Hi everybody, this is Mrs. Houts, and I'm going to give you a pretty quick review of what you've learned so far about ionic versus molecular compounds, naming them, and writing formulas. So you should have your periodic table, you should have a pencil and a piece of paper for doing some practice before you take your quiz tomorrow. So let's get started. Here is this naming flowchart. It's posted on my Schoology page. Probably everybody's got it posted. And we're going to go down these various paths just as a review of the rules that you have learned. So the first thing you do when you're presented with some formula and you've got to come up with the name is you ask yourself, is there a metal? Because if there's a metal, you automatically are going to go down this pathway of ionic naming rules, okay? So if the very first element is a metal, you instantly know you have some ionic compound. This asterisk is there because you could also have the ammonium ion, which is a positively charged polyatomic ion, and you could also get ionic. You also would have an ionic compound, and you would follow the ionic naming rules. So we're going to do some examples of each type, and you really should practice these, and then I'll show you the answers, and you see if you got them right. Okay, so the first kind is just the simple binary ionic compounds where you have a type 1 metal, which you may recall is the kind of metal that will always have its same characteristic charge. So the alkaline earth metals, and aluminum. All right, and the rules are you name the metal, you name the nonmetal, you change the ending to IDE, and you say the name, and that's it. And we'll talk about polyatomic ions here in a second. All right, so for example, practice number 1. Write down the name of this compound, K2O. All right, and then write the formula for this compound, aluminum fluoride. These are both type 1 ionic compounds with a type 1 metal and a nonmetal. Okay, so you pause the video because I'm going to keep going. Write down what you think the answer is, and then you can check. All right, so K2O is potassium oxide. So again, you just say the name of the metal, which is potassium. And oxygen, when it becomes an ion, its ending gets changed to IDE. So potassium oxide is that one. And then the formula for aluminum fluoride, this is where you got to balance the charges. Super critical for ionic compounds. Aluminum has a +3 charge. Fluoride has a -1 charge. So you would need 3 fluorides to cancel out 1 aluminum, and your formula would become AlF3. All right, moving on. So now we're going to go down this other branch of ionic naming when we have a type 2 metal, which is the transition metals. And again, hopefully you can recall that those are a different category because they can have different charges, and we have to use Roman numerals in the name to indicate the charge on the metal. All right, so you name the metal, you figure out the charge of the metal, and you put Roman numerals in parentheses, and you change the ending of the nonmetal to IDE. All right, so let's practice a couple of these. All right, number 3, practice number 3. Name this compound, FeBr3, and number 4, write the formula for this compound, nickel 3 oxide. All right, so you pause, practice this, see if you got it right, because I'm about to show the answer. Number 3, iron, Roman numeral 3, bromide. We know it's going to be iron something bromide, and then bromine has a charge of -1, and there's 3 of them, so that side's a -3. We have one iron, which means it has to have a +3 charge. So make sure you put the Roman numeral in the name when you have a transition metal. All right, number 4, nickel, Roman numeral 3, means it has a +3 charge. Oxygen as an ion has a -2 charge. So again, these ionic compounds, you got to balance the charges. So I need 3 oxygens that add up to a -6 to balance the charges with 2 nickels that add up to a +6. So my formula would have 2 nickels and 3 oxygens. So nickel with a little 2, oxygen, subscript 3. All right, and one thing to note, try not to make this mistake, but that subscript 2 is not the charge on nickel. All right, Roman numeral 3 tells the charge on the nickel. That subscript 2 just tells us how many nickels are in that compound. All right, let's talk about polyatomic ions here for a second. Okay, they are ions, so they have charges, so they would be under the ionic naming category. All right, and the same rules apply. We just don't change the ending of the name of the polyatomic ion. We just take it straight off the back of the periodic table and use that name just the way it is. All right, so most polyatomic ions are negatively charged. In other words, they're anions. And the back of your periodic table, table F, has a very long list of those negatively charged polyatomic ions. All right, so practice number 5. What is the name of this thing? Li3PO4. Okay, so pause, write down the name, and see if you got lithium phosphate. Hopefully you did. PO4 is the phosphate ion, and Li is lithium. So you say the name of the metal, lithium, and you say the name of the polyatomic ion, which is phosphate. All right, write the formula for this compound, calcium acetate. So again, we're still in the ionic category, so we still have to write a formula that balances the charges. Okay, so why don't you try it? I'm counting to 3. See if you got the right answer. Pause the video if you need to. All right, calcium has a +2 charge. Acetate is this polyatomic ion. It's on the very top of that table F, C2H3O2. It's got a -1 charge. So I need 2 acetate ions to balance out 1 calcium. Okay, so remember, when you have more than one copy of a polyatomic ion, it has to go in parentheses, and then the number that you have goes on the outside. So in this case, I have 2 acetates, so that is inside parentheses, and the 2 is on the outside. All right, moving on. All right, there's a few polyatomic ions that are positively charged. In other words, they're cations. For us, so far, the most commonly used one is the ammonium ion. On table F, there's actually only 3 listed, and we'll talk about hydronium another day. So ammonium is really the main one that we're going to come across for you guys. So it's NH4 with a +1 charge, and again, it's an ion, so we would follow the ionic naming rules. In this case, if I have ammonium with a Cl, I just say the name of ammonium, and I change chlorine to chloride. That becomes ammonium chloride. All right, let's switch gears now and talk about molecular compounds. All right, again, look at your formula and ask yourself if you have a metal. If you do not have a metal, you have got yourself a molecular compound, a nonmetal and a nonmetal. And the rules are different, and I believe they're much easier, okay? You're going to just name the first element. You're going to use the prefixes on the back of your periodic table in table E. If the first element, if you only have one of them, you don't say the word mono, and then you name the second element using prefixes, changing the ending to IDE. So this is relatively new for you guys. I think we've only done it for 1 day, but it's really not that bad, I don't think. So let's practice. All right. Remember, they're still binary, so there's 2 elements. Both are nonmetal, and sometimes they're also called covalent compounds. So molecular and covalent are sort of synonymous. All right, here's table E, okay, and here's these prefixes, all right? And when you're looking at the back of your periodic table, make sure you're looking at this molecular naming prefix box and not the organic naming prefixes. All right, there's a little bit of overlap on a few of these things, but this is a whole different category of compounds. So we're going to use this molecular naming prefix box. All right, so let's practice. Number 7, N2O7. Name that one. And number 8, name this one, CO. Okay, so pause the video, write these names down, and see what you get. All right, number 7, N2O7. 2, if you have 2 of something, you use di. If you have 7 of something, you use hepta. So this would be called dinitrogen heptaoxide. Sometimes if there's 2 vowels in the middle like that, we might drop one of them. So you could say heptoxide or heptaoxide. I think your teacher would take either one, okay? And then this one, CO, is carbon monoxide. If there's one of the first element, we don't say mono. So we don't say monocarbon monoxide. We just say carbon monoxide. And again, I've dropped an O because it would be monoxide. So you can drop a vowel and there's 2 butted up against each other. That's pretty common. All right. So now let's write formulas for these compounds. Diphosphorus pentaoxide or pentoxide, carbon tetrachloride. All right, di means 2, phosphorus, so I have 2 phosphoruses. Penta means 5, so I have 5 oxygens. So diphosphorus pentoxide is P2O5. This one, carbon tetrachloride, is CCl4. All right, and you don't need to put a 1 after that carbon if you just have one of those carbons. All right, so let's do a little bit of mixed practice. These are mixed up. We have ionic, we have molecular, transition metals, etc. So when you look at a formula, ask yourself, is there a metal? If there's a metal, you have an ionic compound. You follow the ionic naming rules. If you don't have a metal, then you have a molecular compound and you follow the molecular naming rules. All right, so why don't you try this? Pause the video. All right, give yourself time to think about these. Look at your periodic table. Look at that naming flowchart. Go back if you need to, okay? And give it a shot and see how you do. All right, and I'm going to show the answers, so don't look at the answers until you've tried it. All right, Na2O. Sodium is a metal. It's a type 1 metal, so we just say sodium oxide. All right, this one, K3PO4, potassium is a type 1 metal, so this is ionic. PO4 is phosphate, so potassium phosphate is the name of that. This one, copper, is a transition metal. OH is a pi-atomic ion. It's got a -1 charge on it. So -1 plus -1, because I have 2 of them, is -2. So copper must have a +2 charge. So you have got to put that Roman numeral in the name. Copper 2 hydroxide. All right, this one, S4N4, there is no metal in here and there's no ammonium. I have 2 non-metals, sulfur and nitrogen. So I am in the molecular naming category. And 4 is tetra. So you would say tetrasulfur, tetranitride. Nitrogen's ending still is changed to IDE. All right, and lastly, MgCl2, magnesium is a type 1 metal. Cl is just chlorine, so you would say magnesium chloride. Okay, so that is it, and please see your teacher if you need any help.